So I'm Kiran Gollu, co-founder and CEO of Oodle. We are an observability startup. Today we're going to talk about re-architecting or rethinking observability for the cloud era, especially around how can we cut the costs and complexity that has become like a recurring problem for many companies. A little bit about me. Before Oodle, I used to run the cloud platform engineering at Rubrik, where we were scaling to almost like $500 million in revenue. While there, my co-founder Vijay Karthik and I noticed like a lot of observability challenges around cost, scale, time to resolution. That's what kind of prompted us to start Oodle. Before that, I also founded another incident automation startup that was trying to solve like incidents in an automatic way. Before its time, we were too early to solve the problem. And before that, like early days of Amazon S3, scaling Dropbox, Twitter, and then also early days of DynamoDB. One thing that's common across like last 18 years of my experience has been my passion towards developer products or developer experience that continues to keeps me going. So what will I talk about today? We'll talk about the current challenges in metrics observability. How are people trying to solve those challenges? And what are the requirements of an ideal metrics observability solution? We'll restrict our focus to metrics observability for the purpose of this talk. Why now is the right time to rethink that? And we'll talk about like a new first principles approach to solving that problem. And finally talk about what sort of new use cases that it will unlock, and finally land it with like some results and learnings. We'll show a demo of what we have created. Here is how a typical metrics observability stack looks like. You have some data collection stuff either via agent, or you directly send via API to the observability tool, or either via like you send it via OpenTelemetry, Prometheus, eBPF. That's instrumenting all the necessary metrics, and it is being sent to your storage system. The storage system could be SSD based, some sort of like a time series database, or it could be like an object storage, depending on the type of tool that you're using. So in the case of like, there are like in the data storage, there are two tiers, hot tier and cold tier. And people end up swapping data between these two because hot tier has like fast access, cold tier has like cheaper storage. So people have to wrangle these two. And there are some tools out there like Cribble, which kind of route the data between those two. And there are some other companies as well. This list is by no means comprehensive. And then there's a data visualization layer as well, which provides like visibility into dashboards, monitors, metrics, and so on. So this is what like a typical observability stack looks like, just for context. What are some of the challenges with the metrics observability today? It's expensive. It's the third biggest expense in engineering after your people costs and your cloud spend. And it's also like 25% of your cloud spend. A lot of people here also mentioned that. Tina and then few others. And it's complicated because engineers have, and SREs have information overload. There are too many dashboards to deal with. Way to start first. And then also if it is a self-hosted installation, it demands a lot of engineering bandwidth. Especially the commercial tools have annoying lock-ins. I personally went through a whole bunch of these migration pains while I was actually switching tools at Rubrik multiple times, 6 months, 1 year, multiple quarters. It's very painful. And the last pain point I would say is very important is time to resolution is like skyrocketing with the data growth. Engineers and companies have to choose between budget and visibility. So let's dig a little bit deeper into each of these challenges and what are companies trying to do. If you run like either open source stack, for example, Prometheus, Grafana, OpenTelemetry stack, it also applies to managed open source as well. You need a lot of engineers. You tend to over-provision your CPU, memory, yet you run into kind of like reliability challenges. In the case of commercial offerings like Datadog, Splunk, or Elastic, again, we talked about that. It's a big span. It's complicated. Why is it complicated? If you look at the open source stack again, Prometheus is not horizontally scalable. And there are some newer versions like Thanos, Cortex. They also have like similar challenges at a different scale. they require like a lot of engineering bandwidth. And they tend to break at scale, especially causing like reliability problems, customer experience challenges. If you look at commercial offerings, they do support the scale. However, you have to pay through the nose and you have to put in engineering bandwidth to figure out what to keep and what to throw away. So, and when you throw away stuff that is important, when you need to add it back, it requires like multiple weeks to get the code back. So it's just not like turning on and off dynamically. And the second problem that they introduce is it's hard to attribute usage and costs. You can drop things that are not being used, but they just make it extremely hard to figure out what are you using and what are you sending, basically. It's almost become a thing my co-founder likes to call it. Is it a crime to send high cardinality metrics? So the third problem that we have is like debugging is slow. This is resulting in like high MTTR. If you look at the open source stack, the main cause of this is actually the stack not being reliable as you scale. That results in out of memory issues, query timeouts, right in the middle of a 2 a.m. on call. If you look at the commercial offerings, the key challenge there is like there are too many dashboards. I don't know where to start. And the dashboards are actually like more like a middleman. Why am I creating these dashboards? Why am I maintaining these dashboards? Who is supposed to keep them up to date? My goal is that I have an alert. I need to get in, get out as fast as possible. So there's also a gap between experienced and new engineers as well. So your new engineers are not able to debug as fast as your experienced engineers. And finally, they're not optimized for end-to-end debugging experience. There are like a lot of point tools that show this, and then you have to go somewhere else and then do something else, and then finally come to the conclusion as to what's the root cause. Finally, they have lock-ins. Open source typically have no lock-in problems, except for the fact that if you're using standard open source, that's totally cool. But if you use like a different open source tool, you also have to think about how to navigate away from like the open source tool that you're using to more standard open source tools like Prometheus and Grafana. So it's not completely free. In most cases, it works out fine. In the case of commercial offerings, migrations are painful, takes months and quarters. My time at Rubrik, my CTO used to tell me, business is growing 2x. Why is our observability bill growing like 3x or 2x? Shouldn't we have like better leverage when the revenue grows or when the customers grows? As a software thing, we should have better leverage than like growing linearly. So companies are looking for like sublinear growth in terms of pricing with the data growth, especially given that most of the data is not being used at all. So how are people trying to address this problem today? There are first wave of companies, especially when we're shifting from like on-prem to the cloud. There's Datadog, New Relic, Dynatrace, AppDynamics, Splunk. They solve the experience problem. But now with the explosion of the data, they've become expensive. People stop sending high cardinality metrics, but they do work if you're okay with paying high bills. And there is a second wave of tools, especially around focusing on scale first. So first wave of companies were focusing on experience solving the problem. They did. Second wave of companies, okay, now there's a data problem. I need to make sure that as we scale, this thing has to work. And that's where companies like Chronosphere, Mimir, Victoria Metrics, advanced forms of Prometheus like Thanos and Cortex are coming in. They're solving the problem for scale, yet although they still have some challenges around high cardinality, but they're able to solve it to some extent. But the biggest challenge over there is they're able to reduce cost by a certain percent, but they're not cost efficient, although they can scale effectively. So what they do is like a tiered storage, which is let's move the data between hot tier and cold tier. It does help. It can reduce your cost by 30%, 40%, 50%, but your data is growing at a massive pace, a lot faster than what you can reduce. And this becomes like engineering bandwidth to like figure out what rules should I set up and configure. So it does help, but not enough. So why the legacy architectures won't work for like cloud native workloads? The number one reason is that like they're not architected for cost efficiency from day one. First wave was architected for experience. Second wave was architected for scalability. To some extent cost, but cost efficiency was not a first-class citizen from day one. And a lot of them use like row-based stores which means that high cardinality becomes like a huge challenge. You don't think about high cardinality when you think about like Snowflake, Databricks, you just send it and then you can query it. And they're also expensive because they store the data on expensive SSDs. There are some studies done, I think, which we'll get to later as well. SSDs with replication can get really expensive, especially the cloud disks, as much as 25 times more than your object storage. And adding replication adds more cost. And the fourth problem that they have is always running compute. Why am I running compute all the time for some data that's barely being queried? Ingestion makes sense, but when I'm firing queries, why is query compute running all the time? And lastly, they're all based on like lift and shift on-prem architectures. So what are the requirements of an ideal solution, right? I'll start with two key requirements. Now, we looked at a whole bunch of challenges, how people have been tackling it. The two key requirements of an ideal solution are, one, it should be architected for cost efficiency from day one. Scalability and reliability are table stakes. Number two, speed of incident resolution really matters. I don't need to create like 100 more dashboards. I don't want to edit one more dashboard again at 2 a.m. in the night. On-call engineers should get in, get out as fast as possible and be able to ask any question at any cardinality, because that's the job of the observability system at the end of the day. If it can do both of them quite effectively, then I think you've really designed your observability system effectively. There are some other auxiliary requirements of an ideal solution. It needs to be table stakes, reliable, performant, scalable. It needs to be fast. It needs to be secure and compliant in terms of like offering different deployment models around SaaS so that you don't have to manage a thing, or you want to own your data, bring your own bucket, being able to store all the data so that you have the copy of the data, and being able to differentiate between control plane and data plane. So most vendors, because it's against their interests, they don't provide good cost and usage attribution and visibility. But this is important for the customers. Customers are doing all sorts of manual work, installing, like deploying more engineers to make sure that they get this visibility and then reduce waste. Last one I would say is like no lock-in. It's an important topic here. The difference between open source and open source compatible, I want to emphasize here. What companies are looking for is actually being able to get out fast. Yes, open source is useful. They can maintain it. But at the end of the day, if they can go to a different provider, either open source tool or a vendor fast, that's the table stakes. So that's why I think open source compatible, being able to switch out easily is the key criteria here, not just being open source. So why now is the right time to rethink this? Observability has become a data problem. And there is this like separation of storage and compute phenomena that started by Snowflake. And those innovations are being applied to data warehousing, databases, that people are creating serverless databases, even for OLTP, and streaming architectures are also being reinvented. Can we borrow some of those innovations and apply to observability data to deliver radical cost efficiency and radically better debugging speed? And there's also serverless wave. The performance, being able to like query within 2 to 3 seconds for a P99 latency is possible because there are like a lot of improvements around cold start, latency for serverless, the amount of parallelism that you can have for like Lambdas. Now you can spin like hundreds of thousands of Lambdas very quickly and then have that go against your object storage and then get the results that you need really fast. And lastly, generative AI. Observability data has like few different properties. You mostly care about recent data. Time series data is like highly compressible compared to your analytical workloads. And most of the data that you send is like not being queried. And the queries need to be really fast in real time, unlike analytical queries. And metrics data also has complex aggregations, yet the speed is very important. What's our answer to this? We built a custom storage format exploiting these properties and build it on top of object storage. You saw this diagram before. Earlier, there were tools that were actually splitting the data between hot tier and cold tier. The moment it goes to cold tier, you cannot access it anymore. you cannot query it, or it takes much longer to query it. What if you were to collapse it all and then make it one thing and then make the queries fast? It's almost like making your uh, observability commoditized. When you think about object storage, you don't think about like how much am I spending on object storage. Your first response would be like, am I sending garbage to that? You think about it and then you try to fix your issues rather than thinking that like my cloud object storage is expensive. So can you get to that sort of like level of baseline for observability is the line of thought here. So the truly cloud native architecture here, which I'll not be able to go into much detail, it delivers like radically better cost efficiency and simplicity because it makes the entire architecture stateless. You store the data in your S3 and then you have like lots of lambdas going against them. There are no disks at all in the entire architecture. S3 is like incredibly durable, and lambdas, you can go, I think like they're designed for the scale of internet. So yeah. The last thing that I would say that is very unique and different our approach is actually say no to dashboards. Why have more dashboards, which touched upon, and just start resolving your alerts. I'll quickly cover these things in a demo. So we've created a new architecture, and here's a demo that shows that we're sending like live data. It's available for anyone to play with. It's at play.oodle.ai. This would cost around like $4 million a year. Let me just share the right screen. Sorry about that. So here's a live dashboard that's constantly pumping data. It's about 15 million unique time series per hour, about like 1.5 billion samples per day, per hour, sorry. It would cost around like $10 million, $4 million a year with Datadog. It would cost 1/10 for Oodle. And it's live, people can play with it. It's fast. And then you can actually get to play with it. Here you go. And so that demonstrates the first aspect of it, which is the cost efficiency. It shows at very high cardinality, something that costs a lot. I think we're able to do that like a lot cheaper. And the second thing that I would like to demo here is that ability to debug things fast at any cardinality. So in this case, you can see that there are like a lot of countries, cities, nodes, containers, and I'm going to zoom into a P99 latency here. And I'm going to click a button. And what this is doing is that it is creating a dynamic dashboard that is relevant only for this alert by doing shape matching and then figuring out, okay, what's the reason for this like latency spike? Is it because of is it happening for a specific customer, specific node, specific city? Is there any specific API that corresponds to this? We look at all of that and we do like a dimensionality impact analysis, which is deterministic and accurate because it's actually scanning through all the tags and then surfacing the right things for you. Here in this case, the latency spike is happening because of database too many connections, and it's happening due to a 500 error, and it looks like it's happening from database service. Other services seem okay. And all the services that are sending to database services seem to be impacted. And among thousands of containers, so these are the 4 or 5 containers that got impacted the most. And here is the region that got impacted the most. And this data is available to you before you even like start using your keyboard when you get paged. So the core idea is you can triage in minutes instead of like hours and quickly get to, hey, here's where the problem could be. And we're also expanding on this further by being able to click from here, directly jump into database logs, and then apply generative AI summarization on top of that. At this time, we are leveraging generative AI where it is good at in the summarization aspects. Some of the other aspects, I think we're still exploring in the early days of exploring that. So here you show a quick demo of how cost efficient Oodle is, and 2, how easy it is to like debug problems quickly. Talk about few results. How are we able to achieve like 10x lower compute costs? We were able to achieve them because of our serverless architecture. You don't pay for compute. In the ingest side, we use dedicated compute, but whenever you're firing queries, we leverage serverless Lambda functions. And we also use like intelligent caching whenever possible for fast performance. For example, all your dashboards, the dashboards that were accessed before, We can store them in a query result cache and then make it faster for you. Likewise, in the memory, we don't have any global indexing. We have a custom in-memory representation, which is something that like my co-founder worked quite a bit on designing file systems at Rubrik. I think he borrowed some of that innovations techniques and applying that to observability data as well. We're able to achieve like 24x lower storage by using S3 instead of like cloud disks like EBS. Here, this assumes, I think we borrowed this graph from Bob's Stream blog. This is assuming that like you're replicating the data in a three-way manner, and S3 cost would be like 0.023, and then like EBS would be like 0.48. That's like you're looking at like a 24x cost improvements. One thing which is a surprise for us, which we did not plan for, is that one of the challenges with the like metrics is that like metrics are downsampled. Let's say you want to look at 3 days later. They're all automatically aggregated to a 5-minute window, an hour-long window, or like you lose the granularity or the high-fidelity data during an outage that just occurred. Let's say you're a payment processing platform or e-commerce platform. You need to narrow down to that particular like last 10, in that 10-second window or 15-second window or 30-second window what happened. Most observability tools today can't do that because they can't manage the amount of data that we are able to manage. So I think with our system, by storing the entire data in object storage, we don't have a concept of downsampling. You have high fidelity data all the time. The last thing I would say around like networking is that we're also able to achieve zero networking costs, again, in the spirit of cost efficiency, by pinning down availability zones between sender and receiver. In this case, here is the customer's VPC. From there, if you pin the availability zone between these two, Oodle and customer, and then directly write it to S3, you completely avoid egress costs, and egress costs are down to zero. You pay like a fixed amount of money, which is like $100 or $200. So it avoids a lot of egress costs. When the observability data is like really high, the volumes are like really high. This matters quite a bit. So what I spoke about, just to summarize, we talked about the key challenges in metrics observability today. The two biggest challenges are cost and the time to resolution. The legacy architectures won't work for cloud-native workloads. We talked about a new approach, which is from first principles, that can deliver like 5x faster debugging speed and also 10x cheaper in terms of like cost efficiency. We also talked about a brand new approach, which is dashboard-less debugging. Let's not create more dashboards using Oodle Insights. We're expanding more and more on that with generative AI. And finally, this unlocks some new use cases around high cardinality, looking at things by customer, looking at things by region, looking at things by camera ID, or if you're a security monitoring company, which were not at all possible with existing tools, because if you were to do that, your bills are going to explode by 100x. So I think we talked about that. And then finally, downsampling is a surprise benefit that we learned as a part of this exercise. And here's the team behind it. Me and my co-founder Vijay Karthik and the rest of the founding team. This is the entire team that made all of these innovations possible. A big shout out to them. Thank you very much.